Got it. Okay, shall we start our discussion? This is grade 10 revision class. Grade 10 revision class or other paper class. You can find us from these resources. You can log into Anhydrous.com. From there, you can find me out. Anhydrous.com 7181 461 83. WhatsApp or give me a call so you can connect. And this is we're going to discuss about the answers for the questions. The paper is sent to you in advance. You might have got it from your group. So all organisms are made. This is part B of the first term test paper. Organisms are made up of single or multiple cells. A and B below show two types of organisms. Two types of organisms. Two types of cells of organisms. Right. You can understand what A and what B. Which letter denote animal cells form A and B? Animal cell is A, and these are cheek cells. So you know the cheek cells that taken from your mouth, and that represent the animal cells. Then you have the onion cells or the cells taken from the rohio paper, the rohio plant. You might have seen the rohio plant, which is a purple color plant, and these are we can observe onion cells. Onion cells. I will show you some onion cells and the low power. Well, these are onion cells. How can I show you that one? Yeah, these are the onion cells. As you can see that onion cells have the boundaries. This may be mid power. As you can see, the onion cells have the boundaries because of the cell wall. Cell wall is very hard because it's made up of cellulose, and later the lignin can be deposited in the cell wall, and the plasma membrane inner to the cell wall, and it has large vacuole. These are the nucleus, and the color, the blue color is taken from methylene blue. It's a stain. If you don't have a stain, you can't see it because it's transparent. And even you can see the plant cells from the rohio epidermis plant. Rohio plant, if you have not seen, you might have seen the purplish color rohio plants. They are there. We can get the epidermis of the rohio plant as well. The beetle plant leaf can be taken to observe the inner parts, right? So when you just look at the cells of the rohio plants or the onion cells, you can observe them, and the cheek cell. In contrast with the cheek cells, the cheek cells are different from the plant cells. I'm going to show you some cheek cells. See the difference between the animal cells and the cheek cell. These are cheek cells. Cheek cells. Yeah. I'm waiting for some other people to come. Still, they are joining. Cheek cell, and this is plant cell, and chick cell. Chick cell represents the animal cells and the plant cells. There you got. See the difference between these two. And we have to do some studies about this. This is how the chick cell is taken. You have to use a toothpick or maybe you got a spoon you can take to find out the chick cell. Well, this is all about the plant cells and animal cells, and the question goes on that one. Which letter denote animal cells? The animal cells is A because that's a chick cell. And name a specimen that can be used to observe about cells, that animal cells. The specimen is taken from the chick cells from the mouth. So the answer for this one is chick cell. Chick cells. Well, identify and name the organelles given below. Well, this is mitochondria. This one? Mitochondria. Ribosome. Ribosome. Mitochondria, ribosome and what is this organelles of the cell? No idea.
Nucleus.
Yes, exactly. It is. This is a plant cell. I will show you animal cell. Before going to the discussion, animal cell, some of you might have not an idea about what it is. I'm not going to show you a 3D one here, because if you are to go for the 3D one, then you will not get a real sense of the pictures that you have in your the exam paper. As you can see that here, there is nucleus. This is nucleus, and you can have the nucleolus. Nucleus, the nucleolus. This is an animal cell. The shape is not that regular shape, just like the plant cell. And the ribosomes are there. You can see the ribosome, Golgi apparatus, endoplasmic reticulum. Mitochondria is there. The shape of the mitochondria is just like a cucumber one. Yeah, those are the things. And large vacuole, they might be available in the plant cell. And I'm going to show you the difference between I'm going to show you animal cell and the plant cell. If you can see this one, you can see the animal cell and the plant cell, right? With the idea about this one, because we are not going to learn the theories, I just gave you a little reminder of what we have to study. And when you go to identify and name the organelles given below, so as you told, this is mitochondria. This is mitochondria. Mitochondria, ribosome, and this one, nucleus. Write separately the functions performed by A and C. A is for protein synthesis. C, controlling the cellular activities and transferring the genetic information from one generation to next. So the ribosome, you have to write, where is it? Write separately the function performed by A and C. So there you have to indicate that you are going to write the function of A and the function of C. You want to not B, right? Write a separate function of A and C. I'm sorry, I just told you about B. A, the function of A is cellular respiration conducting cellular respiration conducting the cellular respiration A mitochondria, and C controlling the cellular activities. Controlling the cellular activities. Controlling the cellular activity. Next question. Name the chemical substance by which cell wall is made up of. What is it?
Cellulose.
Cellulose. Yeah, answer for the fifth one is cellulose. Cellulose is a polymer of the monosaccharide glucose. Glucose is polymerized and the cellulose is made. Next one. Name two characteristics found in plant cell that I can't see that one. Yeah. Name two characteristics found in plant cells. Name two characteristics found in plant cells that you do not see in animal cells. The things that is available in plant cell but not available in the animal cell. What are they?
Cell wall.
Cell wall.
Availability of cell wall and the
Chloroplast.
Chloroplast or chlorophyll?
Chloroplast.
Yeah, chlorophyll is inside the chloroplast, so you can say chloroplast. Availability of chloroplast, availability of the cell wall and large vacuole. Available of large vacuole, and if you are going further, animal cells have glycogen granules and the plant cells have the starch granules. Starch granules available, but basically you want to write the major parts. The sixth one, number one, the difference asking, plant cell has the cell wall B, chloroplast. Apart from that, if you are interested in writing, you can say what? The glycogen, starch granules can be available. Next one. Name two facts found in the cell theory. Name two facts found in the cell theory.
Structural and functional
Structural.
unit of life is the cell.
The structural and functional unit of the life is cell.
All organisms are made of one or more cells.
All the organisms are made of one or more cells. I'm not going to write it. Okay. As it takes. What's the one? First one?
The structural and functional unit of life is the cell.
The structural and functional unit of the life is cell. The structural and structural, the structural and functional unit of life is the cell. That one and the other one. all the organisms are made of either single cell or many cell, single cell or many cells. The question paper is given in your WhatsApp group. So everybody has this question paper, and we are discussing the answers. So you can write down the answers. If you still don't have the paper with you in your hand, you can get it once you get into the particular WhatsApp group. Right. Next one, B. The question has A, B, C parts. The B part, we are discussing the second part. B. One step of an activity performed to identify a certain nutrition in a student's food is given below. As you can see, what is the step? The first one is food extract. Then reagent P, floating of red fat globules. What is the nutrient identified in the food extract?
Sudan 3.
What is?
Lipid.
Sudan 3.
What is the nutrient identified in the food
Lipid.
extract?
Lipids.
What is it?
Lipids.
Lipids.
Lipids. The answer is lipids. You should not get hurry when answering. We know the answer, but sometimes because of our recklessness that happens, so the answer for this one is, what is the nutrients find in the food extract? Lipid. That's lipid. Name the two elements that has contributed to build up that nutrients. Name two elements. Name the two elements.
Hydrogen.
Carbon and
Hydrogen.
hydrogen. Carbon, hydrogen. Can you say name the two elements? Name the two elements. What does it mean? That means lipid is made of only two elements. It is not, right? Carbon, hydrogen, you can have oxygen.
Fatty acids and
I didn't hear you actually. Well, name the P reagent in the above diagram. That's your answer. What's it?
Sudan 3.
Sudan 3.
Sudan 3. Sudan 3. Name a lipid components there. You got the answer. Lipid component that helps in the formation of cell membrane.
Phospholipids.
Phospholipid, right? How to write phosphor? PHOSPO, phosphorus, phosphor. Phospholipid. Phospholipids. Name the chemical substance and explain the observation you got in the activity to identify that water is present as a component in food. Yeah, the first part. Name the chemical substance, and what is the chemical substance you use to find out the water in the food extract?
Anhydrous cobalt chloride.
Anhydrous
Copper chloride or copper sulfate.
copper sulfate. Anhydrous copper sulfate, copper chloride, copper sulfate, which is white. So the observation, anhydrous copper sulfate, anhydrous CuSO4 is white. when water is available, the color is, what is the color? Blue.
Blue.
The color is blue. I'm going to show you anhydrous copper sulfate and the hydrous copper sulfate. This is anhydrous copper sulfate and the hydrous copper sulfate. Okay, anhydrous copper sulfate and hydrous copper sulfate. 1 second. Anhydrous copper sulfate, anhydrous CuSO4. The color is white. The color is white. There you got both. Here you got the both. Normally you can't have this anhydrous copper sulfate at the atmosphere because the atmospheric water vapor is quickly absorbed and then turns into the blue color. So this is hydrous copper sulfate and this is anhydrous copper sulfate. Anhydrous copper sulfate is taken when that the water is available, it turns into the blue color. Right. Then next point, according to our question, name the chemical substance and explain the observation you got. Explain the observation. Explain the observation. Write the observation, right? Observation is that anhydrous white color turns into blue color. Observation is white color, whitish powder makes its color change into blue color or whatever it is. Name a deficiency symptom that you see in plants due to the deficiency of mineral calcium. What is the calcium deficiency? What is the deficiency of calcium?
Weakening
Huh?
bones.
The tips of the leaves.
Tips of the leaves. What happened to the tip of the leaf?
Die.
Dying tissues at the tips of the leaves.
Yeah, die tissues at the tip of the leaves. Calcium deficiency of plant. You know what happened to the calcium deficiency? The tip of the leaves dying. Can't find. Something like this. Calcium deficiency. Right? So you have to give the immediate treatment. Look at here. This might be perfect. Calcium deficiency. Tip of the leaves are dying. Good. Going to the next one. Part, what is it known as? No. Name the deficiency symptoms that you see the plants due to the deficiency of mineral calcium. The tip of the plant leaves dying. Can I go to the 10th one? Next question. Yeah. Okay. Sixth, this question we are going to discuss. Sometimes you might find it hard to answer this one, and I'm going to get the space to answer, find the space for answering it. Right. Shall we read that very carefully? Right. All the elements of the third period in the periodic table are given below. Jumbled order. Third period, and all the elements are given. How do you start the third period? Hydrogen, helium? Yeah,
Sodium.
Sodium, magnesium.
starting from the sodium. Right. ඊට පස්සේ then periodic table.
Sodium, magnesium.
Sodium, magnesium,
Aluminium,
aluminium, silicon,
phosphorus,
sulfur, phosphorus, chlorine, argon. As you can see, this is the periodic table. And you can find out that sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. But the question is set by using the periodic tables, the third period. These are groups. First group, Roman number, second, third, something like that. You can go for the last one. And these are periods. 1, 2, 3, 4. And if you consider aluminium, aluminium's atomic number is, what is it? 283. Atomic number is 13. So it has the last energy level, the valence electron free, which indicates that it belongs to the third group. And when you have 3 energy levels, that indicates it's in the third period. So third group, third period, aluminium is available. So I just gave you some simple idea about this one, and then we'll go. Write down the above jumbled elements in the correct order of the periodic table. So you know what it is, then how do you write it?
sodium, magnesium,
Sodium, magnesium,
aluminium, silicon, phosphorus, sulfur, chlorine, argon.
from where should I find it out, right? If I make it smaller, can I share your screen? I will share the screen. That will be nice, I think. Then you can see it very clearly. Can you see the screen now?
Yes, sir.
Which way is better? This way is better?
Yes, sir.
This way is better. Right. Write down the above jumbled elements in the correct order of the periodic table. So I'm writing the first answer, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Write down the chemical formula of the most basic and most acidic oxides from the above list. Write down the chemical formula of the most basic and most acidic oxides from the above list. What is the most basic one?
Sodium
Sodium,
Okay, sodium,
oxide.
sodium
sulfur,
oxide. Sodium oxide. What is the most acidic one?
Chlorine.
chlorine,
Right, chlorine.
oxide.
You want to write one? Chemical formula of the most basic and most acidic oxides. I don't know whether you have learned the acidic oxide of what? Acidic oxide, chlorine. I don't know whether you have learned it. Have you? Have you learned that one? HOCl. Have you learned that one? Chlorine oxide. It's not in your syllabus. I don't know why it is given. But one thing is here. If I explain you right, when you come to the periodic table, when you come to the periodic table, right? The periodic table has something like this. Okay. The metals, that means lithium, beryllium, aluminium, right? Calcium, sodium, magnesium. They make the basic oxides. They make the basic oxides, right? So you can have magnesium oxide. And when they are with the water, they make magnesium hydroxide, sodium hydroxide. The strongest oxide is sodium. There's no harm, no problem. Na2O. But the problem is coming from the other side, right? These are acetic oxide. When you go for like chlorine side, they are more acidic. So what is the oxide of chlorine? Chlorine with oxygen. I will learn that one. Huh?
Cl2O7.
Cl2O7.
Cl2O7. Okay. Cl2O7. But I don't know whether it is available in your syllabus. Is it
Yes, sir.
Yes, sir.
available? I can't remember. Cl2O7. Okay. And that from there you learn that more basic substance available from the oxides of metals and acidic oxides available with the non-metallic oxides. Well, what is the safety precaution taken in storing the sodium metal?
Stored in paraffin oil or
Kerosene, because it's not kept in the normal, exposed into normal air, because it reacts with the water vapor. Therefore, it's stored in kerosene oil or paraffin oil, as you told, kerosene oil. So the answer for this one is, storing. So let me write the answers for the first part. Write down the above jumbled elements. We wrote that one: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. The second one, write down the chemical formula of the most basic, Na2O. But the other one, Cl2O7. Third one. What is the safety precautions? So storing in kerosene oil. Storing in kerosene oil. And what's the fourth one? Write down the electronic configuration of the element which has 4 electrons in the valence shell from the above element. So what is the that one? 1, 2, 3, 4. Silicon. Am I correct?
Yes, sir.
Yes, sir.
284.
So you have to write silicon. What is the electronic configuration? 2, 8, 3. 2, 8, 4. 2, 8, 4. 2, 8, 4. Because this is in the third period. Then when it is in the third period, you have to write three energy levels. And as it is in the fourth group, you have to write the 4. Okay. And next one. What's your next one? Next question. The space is not enough. Write down the electronic gap. Write down 2 instances of using silicon element
For computer parts,
to make in the
computer equipment.
Transistors and
diode.
diodes.
To make diode. To make diode. Another one?
Make solar cells.
Well, to produce solar cells. What? Anything else?
Making transistors and diodes.
The use of silicon. What is the question? Write down 2 instances we are using silicon elements. Glass industry. To produce glass. All these semiconductors, diodes, semiconductors, or electronic equipment. Okay. So, and 6th one,
So glass හදන්න ගන්නවද?
silicon.
glass හදන්න boron නෙමෙයි.
Boron, when you are making this, what? The boiling tubes, something like with the high temperature, right? Silicon is used for the silica, we call that the gum even. Silica, silicon is used for glass industry. Glass industry. Silica, otherwise known as industrial sand, provides the most important ingredient for glass production. Silica sand provides the essential silicon dioxide required for glass formulation, which makes silica the primary components in all type of standard and special glasses. If you want to know them, I will erase this one, delete this one, and I will get that statement here. Okay. I'll get that statement here. Look at there. Silica. The glass industry. Paste. Okay. Read this one. Where is it? How can I get it? Can you read that? Silica, otherwise known as industrial sand, provides the most important ingredient for glass production. Silica sand provides the essential silicon dioxide required for glass formulation, which makes silica the primary component in all types of standard and specialty glasses. Agreed or agreed? Can you agree with me?
Yes. Yes.
Yeah. Next one. Which one? Which question? The problem is when writing the answers for the questions, because the limited space is available for me. Okay, so I clean them and rearrange them. Which part is there we want to talk? Question number? Question number? Question number?
6B part.
Write down instance, okay, B. Question number 5. A student put a small piece of sodium into water under the direction of the teacher and made the observation. Well, what happened when sodium is put into water? When sodium is put into water, right? It reacts with it reacts with water, and it makes sodium hydroxide and hydrogen gas. Sodium hydroxide and hydrogen gas. So that's the reaction. How many, if you are to balance this reaction, how are you going to balance it? If I put 2 over here, and will it be all right? 2 over here and 2 over here. 4 hydrogen, 2 oxygen, 2 oxygen, 2 sodium. Good. And this hydrogen gas, with the heat energy emitted by this chemical reaction, will start to react with oxygen. And as a result of that, we can see a huge flame. So suddenly it produces the flame. So it's very dangerous. And see what happened. Write down 2 observations made by the student in the above activity. When sodium metal is put into water, the chemical reaction. Have you seen that one? Have you seen? Yes or no? Have you seen the reaction sodium with water?
No.
Yes or no?
No, sir.
I'm going to show it. For the convenience, I'm going to stop sharing it one, and I'm going to take this one out. Let me have the video. Okay. So going to see this one. Chemical reaction.
We'll go down the column on the periodic table in group 1 and look at sodium. Like the lithium, the sodium is stored in a mineral oil to minimize reaction with the oxygen in the air. If we remove a piece of sodium metal, we notice that it's also coated over with an oxide coating. Group 1 metals become softer as you go down the column. The sodium is much easier to cut than the lithium. As we cut off the oxide layer, we can see the shiny metal underneath. It coats over very rapidly with a layer of oxide. The sodium is a metal and is an excellent conductor of electricity. If we take a piece of the sodium metal and add it to water, we notice a much more rapid reaction with the water. Like lithium, the sodium is less dense than water and floats. The metal moves across the surface, being pushed by the hydrogen gas that is produced. As you go down the column with group 1 metals, the melting point of the metal decreases. The reaction is very exothermic, which causes the sodium metal to melt.
Okay.
The metal contracts into a very compact spherical form. We can again test that hydrogen gas is being produced by this single displacement reaction by trapping the gas and testing its flammability.
It makes the pop sound.
We can test for the fact that we produce sodium hydroxide by adding phenolphthalein. Phenolphthalein turns
Phenolphthalein
a purple red
turns into pink color.
color due to the presence of the hydroxide ions, indicating the formation of the sodium hydroxide.
Okay, you learned that sodium is stored in the kerosene oil,
Coated over with an oxide.
mineral oil, and it is a soft metal that you can cut easily, right? You can cut it easily.
The sodium is a metal,
and it conducts electricity as
and
well.
is an excellent conductor of electricity.
It conducts electricity.
If we take a piece of the sodium metal and add it to water,
Okay, what are the two observations when you see it in the water? What are the two observations that when it is in the water you can see? Yeah. One,
Float on water.
it floats on water. That means the density of sodium is lesser than water. The other one, it rapidly reacts with water. It rapidly reacts with water and a gas is produced. When the gas is collected and tested with a glovinous splinter, it makes the pop sound, indicating that the produced gas is hydrogen gas. So that's what we wanted to study in this one, and then we'll move to the question. Based on this experiment only, we have to answer these questions. So, write down observations made by the students in the above activity. A student put a small piece of sodium in water under the direction of the teacher and made the observations, right? Do you want me to share the screen?
No need, sir.
Okay. Write down the observation made by the students in the above activity. Mention two physical properties of sodium metal. Write down two physical properties of sodium metal. What's the first one for your answer? Write down the observation. Observation is, you can write two observations. One, sodium floats in water. Sodium floats on water. Second one, you have to write only one. It rapidly reacts with water. It rapidly reacts with water. It rapidly reacts with water, and this actually write down the observation. We can write two observations. Mention two physical properties of sodium metal. We observe that two properties. One,
Can be cut with knife.
yeah, it can. It's a soft metal. It's a soft metal even cut by the knife. Most important two,
Density is lower than water.
density is lower than water.
Good conductor
Conduct-
of
Conduct of
electricity.
heat and electricity.
Conduct electricity. Yeah. So the two observations we saw are, I don't know the exact place where that I should trace it out, made by the students. Mention two physical properties. Part B, third answer. Mention mention two physical properties. One, density is lower than water. Density is lower than water, and the other one, conduct electricity. Conducts electricity. Those are the answers. Write down to the different forms of the same element are known as allotropic form. The different forms of the same element are called allotropic forms. Well, allotropic forms. Then write down two amorphous forms of carbon. Write down two amorphous forms of carbon. What are they?
Ash.
Charcoal.
What are they? Huh?
Charcoal
Limestone.
and coal.
Charcoal.
Charcoal,
Coal.
Coal.
Limestone.
limestone. Yeah. Limestone, charcoal, limestone and charcoal. Write down two physical properties. No. See, write down an instance of using amorphous form of carbon. Write down two amorphous forms of carbon. I don't know whether the reference is amorphous or allotropic form, right? It may be allotropic form. Write down the two allotropic forms of carbon. That is should be there. What are the then what is your answer? Through two allotropic forms.
Crystalline
Form, amorphous form.
Amorphous form and the crystalline form. Give me an example for amorphous form. Lamsot. And crystalline form.
diamond,
Graphite,
Diamond,
carbon graphite.
graphite,
Graphite. Yes, carbon, graphite. Write down instances using amorphous of carbon. Write down, what are they? Amorphous of carbon is used. What are they? Write down an instance of using amorphous carbon. Oh,
black color ink,
vulcanizing rubber,
producing black color ink,
producing
black color ink,
black color ink. Yeah. Even we use to paint the blackboard, to make the blackboard. Don't we use them? Write down amorphous forms of carbon. You can see any of that, making the color, making coloring, applying, making the blackboard. Right? Mention the allotropic form of the carbon with the highest density. Mention the allotropic form of the carbon with higher density and write down the use of it. Now, what is your answer?
Diamond.
Well, mention the allotropic form of carbon is
Crystalline form.
crystalline form. The idea is something, but the language is something else, right? So what is your answer? Is it crystalline form or diamond? According to the question, it is a crystalline form, but the answer is diamond. Mention the allotropic form of the carbon with the highest density. The answer is diamond.
making jewelry,
Diamond. Yeah, making jewelry, glass cutters. For the glass cutters, you use diamond.
cutting gems,
Gems. Can I go to the seventh question?
Okay.
Most of you find it harder to answer the questions of this sort. Okay, let's give a try. Not that hard one. Right. The velocity time graph of the vehicle moving along a straight line is shown in the figure below. Right. The vehicle moves in a straight path. So it is a linear motion. So we know that acceleration, deceleration, and constant or uniform velocity, acceleration to the same direction, acceleration to the opposite direction. If you can remember them, I'm going to give you a little reminder of what they are. Like here, if you use, okay, I'm going to clean this part. Right. Let me see what is this one. Polar velocity time graph, okay? What is this one?
constant velocity,
Constant uniform acceleration.
This is
acceleration,
uniform acceleration Uniform acceleration to the particular direction. To the particular direction. And if you can have a graph like this, right? And what about this one?
Uniform acceleration to the opposite
to
side.
the opposite direction.
Yeah, uniform acceleration to opposite direction. Opposite direction. It is to the opposite direction. Velocity is towards the opposite direction. And what about this one? What about this graph? If you can have a graph like this, polar velocity time graph. This one?
Constant velocity.
Constant
Constant or uniform velocity. Uniform velocity. And what about this one? VT graph.
uniform deceleration.
to the particular direction.
Uniform deceleration to the particular direction. Uniform deceleration. Deceleration to particular direction. Particular direction. Uniform deceleration to the particular direction. It goes to the same direction, but you reduce your acceleration. You reduce your velocity and then comes to the rest maybe. Right? Okay, then with those knowledge, we are moving to the question. According to the graph, state the nature of the motion OA, AB, BC. I'm going to write it on the graph itself. Well, right. According to the graph, okay, state the nature of the motion in OA, AB, and BC. OA, this one.
Uniform acceleration.
Uniform acceleration. Uniform acceleration. Then,
Excuse me, sir.
yeah.
Sir, may I thought to the particular direction kila daanda unnandi.
You have to mention because sometimes it will be there is an insect, you know, that it gives trouble. Uniform acceleration, like there are some occasions that you get confused with that one. And that's why I told you that to the particular direction. Normally in this exam, that answer will not be expected, right? In any case, that sometimes that you have to read the question. Once you read all the questions, you can understand whether you should write some extra information like to the particular direction, to the opposite direction. It is not compulsory. It's not compulsory. But I just told you in order to get an idea, otherwise you will get confused. Because most of the children, they say, this one is deceleration. You just make a little bit of research, do a little research with your friends and ask, you ask about this one. And if this is velocity time graph, and then you say A to B and B to C, right? What sort of motion from AB?
Uniform deceleration.
Uniform deceleration.
Uniform deceleration. And what about this one?
Uniform acceleration.
Uniform acceleration, right? And can you give me one example for this incident?
Throwing a ball upward.
Throwing the ball upward throwing the ball upward, correct? Exactly, yes, because there is initial velocity by the time the ball is released from your hand, right? The ball is still not moving independently. The hand is moving. By the time that the hand is stopped and the ball released, that's the beginning, initial velocity. So the initial velocity is there with a high value, but it moves up, then negative negative acceleration, that's gravitational acceleration, negative value is there, 10 meters per second square. But this is the top position, top over there, because this goes to the particular direction. It moves to the particular direction with the negative acceleration. And then from the top it stops. This is the top place. Not this is the initial stage, initial position, no. This is the top position. And the distance we travel, you can find it out by calculating the area. Right now it is up over there. It is thrown from your hand. It is thrown from your hand, and the ball moves up. So the position is here, topmost, and then it turns back or turn around. And when it comes fast, as you can see that it's increasing the velocity. But the difference between this one and this one is this moves to the particular direction, acceleration, increase in the velocity. And this is also increase in the velocity, true, but to the opposite direction. It moves towards the opposite direction, not in the opposite direction. Not in the opposite direction, it is still in the particular direction, but it turns back and moving towards the opposite direction. Once he passes the initial position, it will be in the opposite direction, in the opposite direction. Okay. Can you understand this, what I said?
Yes, sir.
Yes, sir.
Nice. And moving to that this way, right? Calculate the now what is the max? State the nature of the motion OA, AB. AB is constant uniform velocity. Uniform velocity. And BC.
Uniform deceleration.
Uniform deceleration.
Uniform deceleration. Uniform deceleration. Not towards the opposite direction, no. It's moving to the particular direction. Not opposite direction, right? It's not still opposite direction. And it stops. If it turns back, it can go the same direction or it can go to the opposite direction.
Towards initial position?
No. It's not towards initial position. You didn't get what I said. Let's have a look at that. Let's have a look at here. Let's have a look at here. Okay. Okay, go with me. Go with me. Incident. This is the initial position. Initial position. Right. The ball is in the ball is in the initial position. And I'm going to make the graph representing this one. Okay. This is zero velocity. This is time. Now, the velocity is 0. It does not have initial velocity. Therefore, the graph, we are going to start from here. And this starts to increase its velocity. This is going to increase its velocity. How? Velocity is increased, something like this. Look at here. How is it going to increase its velocity? Something like this. From slowly increase, and then with the same velocity moves, and then you reduce. And stop. Could you understand that? Back. Zero velocity, and then increase the velocity rapidly, increase rapidly, and move with the same velocity, uniform velocity, and then you stop. Now it stops here, moves rapidly, and then constant velocity, and then slows down, and stop. Velocity is 0. Velocity is 0. The distance that the object moved can be calculated finding the area of this one. If this is 3, if this is 5 or 3, and if this is 6, and if this is 8, what is the total, what is the distance that it moved to the particular direction? Area. That means here it is 3, 3 plus 8 divided by 2 multiplied by 3, height. Didn't get what I said? You have to add this length and this length together. This length is 8 plus this length is 6 minus 3, 3. Then you have to divide it by 2. Add this one and this one and divide by 2. And then multiply it by this height. That's 3. Right? So it has moved this much of length and represented by the area of the graph. When, in case that it turns around, and then it gradually increase the velocity, and up to this point it increases velocity and will be continuing with the same velocity, and then we'll be reducing the velocity and come to the 0. So that means you need to have same sort of thing, but in the opposite side of the graph, the Cartesian plane. And the area is the same. This upward movements, this area, downward movements, this area. As a result of that, it's 0. Now it is in the initial position. In any case, that this side is further, with larger area, that means it has passed the initial position. I think you could get a very good understanding about what I said. Am I correct?
Yes, sir.
Got it?
Yes.
Yes.
Right. Then let's move. Let's move to the other part. Where were we? Calculate the displacement now. Calculate the rate of no. What is the maximum velocity? Is that an either of okay? OA, uniform deceleration. That's correct. And then this one. What is the maximum velocity of the train? It is easy. 15 meters per second. it is 15 meters per second. Calculate the rate of change in the velocity of the vehicle during first 3 seconds. First 3 seconds. Calculate the rate of change in velocity of the vehicle during first 3 seconds. Did you find the answer? Did you find the answer? No. This says when the graph is something like this, and if the value is 10 over here, and this is 15, right? The rate of change of change in velocity within 3 seconds. The asking one is within 3 seconds. Okay. So you want to know that whether it is 3 seconds or whether it is 10 seconds, the velocity is, sorry, the rate of change of velocity is, it's a uniform value. It's always constant. So you can find out within 3 seconds or else you can say 10 seconds. And the rate of change of velocity will be the same. I mean, acceleration is always the same. It is not changed, right? So you can find out that if you say 3, then we don't know what value is here. 10 is 15, but we don't know when it is 3, what is the velocity of by that time when the 3 second is there. Therefore, you may take the whole 15 and 10. Then you can say rate of change of velocity. Rate of change of velocity equal acceleration. It is acceleration, and acceleration is equal m. What's m? Gradient. M is gradient. So the gradient can be calculated by dividing the change in y and change in x. So you are going to find it out. Change in y and change in x. So here the change in x is 15 meters per second minus 0 meters per second, and time 10 second minus 0 second. So you got 15 meters per second upon 10 second, 1.5 meters per square second. But you are not going to stop there, and you can write as the acceleration is uniform at 3 seconds. The acceleration is 1.5 meters per second squared. Meters per second squared. Do you agree with me in that point?
Yes, sir.
Yeah. Yes or no?
Yes, sir.
Okay. Now, there are some more grade 10 children coming from different part of the country. I'm not going to tell the place where they are coming. You know that when those things are revealed, these hackers are there hunting for the telephone numbers, and then they are going to add into their group and send you this one and that one and blah blah blah. So please, if you want like these areas to make it more clear, I can arrange a special 2 hours class free of charge within this before starting the school during the daytime. I mean, the 8 to, not tomorrow, maybe some other day. So if you say that, sir, sorry, we can't understand those stuffs with the graphs and all this acceleration, rate of change of velocity, blah, 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 confusing. So we'll discuss that one because it has two variables, you know, that independent variable is time and the dependent variables may be velocity, maybe acceleration. So we can have that kind of session if you are interested in. But when the school starts, we will be busy with the school apps. Okay. What's the other one? Calculate the rate of change in velocity of the vehicle during first 3 seconds. We found out. Calculate the displacement from A to B. Calculate the displacement from A to B. So the displacement is equal to the distance. The displacement here is equal to the distance. Why do I say? Why do I say? The displacement is equal to distance, magnitude-wise. What they are asking is the displacement, so you have to find out first the magnitude. The direction is no problem because it's moving to the same direction, the particular direction. Therefore, we want to calculate the magnitude, and the magnitude can be calculated by finding the area that depicted by the graph. So area is given by this. What shape is it? This rectangular. What's it?
Rectangle.
Yeah, and then try to find out that answer. So the area depicted by the graph can be the magnitude, right? Calculate the displacement from A to B. The fourth one. Going to find out the fourth one. Displacement equal area depicted by the graph. So you can see the graph is 1800 minus 10. 1800 right, minus 10, right, multiplied by 15. Am I correct?
Yes, sir.
Then 1790 multiplied by 15. Is it correct?
Yes, sir.
So then what's the answer? The better calculators, just tell me the one. 1790 multiplied by 15. I'm lazy at doing 26,850. 26,000 850. Am I correct?
Yes, sir.
Yes,
Can sit up to the particular direction, to the particular direction. 26,850 meters to the particular direction, because you are asking, it's asked about the displacement, not the distance. So then direction is also mentioned. What are the two instances of applying an unbalanced external forces on the vehicle according to the graph? What are the two occasions unbalanced force is applied? As we discussed last Saturday, it is the second law of motion of Newton. And it says F equal ma, right? F equal ma. When, according to the Newton's first law of motion, when an object travels with a constant velocity, right, the forces are balanced. That means the forward force is equal to the backward force. So keep moving with the constant velocity in this occasion. But when you want to have an acceleration, unbalanced force should be applied. Or if you want to bring or reduce the velocity, then again you have to apply unbalanced force. But when it is the positive acceleration, I mean acceleration increase in the velocity, the force is given towards the direction of the motion. Whereas the deceleration, then the unbalanced force is applied to opposite direction of the motion. If the object is moving forward, so you want to apply unbalanced force backward, then only the object brings to the stationary position. So according to the ask, what are the two instances applying on unbalanced external force on the vehicle? OA occasion, the answer OA and BC. So they are the one. To state the two facts of the Newton's second law of motion. Newton's second law of motion indicates that F equal ma. So the acceleration is directly proportional to the unbalanced force applied. Acceleration is directly proportional to the force, unbalanced force applied. When unbalanced force is there, capital F. So then one point is that one, unbalanced force applied. Second one, it is inversely proportional to the mass of it. Inversely proportional to the mass of it. And second one is the mass. So the first one is force, unbalanced force. Second one is mass. So state two facts of the Newton's second law. So you are writing one. Remember to put the adjective for the force. First one, mass of the object or mass of the object, mass of the object, and the second one, unbalanced force. If you say force acting on the object, it is wrong, the answer. If you say force acting on is not correct, because you have to mention unbalanced force. The word unbalanced should be referred. Okay. To state the two factors. So then we mentioned that and calculate the force acting on the vehicle during first 10 seconds if the mass of the object is of vehicle is 1,200 kilograms. Now, according to the graph, we know now acceleration. What is the acceleration we find out in this instant? What's the acceleration?
1.5 meters per second.
1.5 meters per second squared. So that is the acceleration. And the mass is given. That is 1,200 kilogram. So unbalanced force is asking. According to the Newton's law of motion, Newton's second law. Now we know M, 1,200, and this is 1.5. So, what is it? You want to add 1,200, and half of it is 006. Together, 8,800. 1,800 Newton. Am I correct?
Yes, sir.
1,800 Newton. 1,800 Newton towards the direction of the motion. Towards the direction of the motion, not opposite direction. What is the advantage of wearing seat belts by the passengers traveling in the vehicle? You can say just your idea, but you have to refer to the Newton's first law of motion. What is the advantage of wearing the seat belts? You have to write according to the Newton's first law of motion. When the vehicle stops, passenger moves forward. In order to stop the motion, the seat belt is essential. So in whatever way that you are going to coin out your words to make the answer for this one, we expect the reference to Newton's first law of motion. And that is what the expected part in your explanation. I will say again, I'm not going to write it a bit longer. What is the advantage of wearing seat belts by the passengers traveling in a vehicle? Say, according to Newton's first law of motion. According to Newton's first law of motion. According to Newton's first M capital motion, the object with uniform velocity would travel even though the vehicle would travel even though the vehicle stops. If there is seat belt, the object kept stick to the seat and prevent from moving forward and hitting on dashboard or steering wheel, vice versa. So it can be a bit longer answer, a little bit of longer answer. And my last part, calculate the momentum of the vehicle during the motion from A to B. Momentum is equal to mv. It's pretty easy. Momentum is equal to simple m, simple v. Mass is 1200 and velocity is, what is the velocity? 15 meters per second. 15 meters per second. So the momentum is the product of 1200 multiplied by 15. What was the answer? We found it up earlier, right?
18,000.
How much is it?
18,000.
Yeah, it's 18,000 what? 18,000
kilogram
kg
meters per
meter.
second.
kilogram meters per.
So 18,000.
I'm sorry. Calculate the weight of the above vehicle. So it's a simple phrase, vehicle W equal mg, m1200 kilogram, and gravitation is taken as 10. Then it's 12,000 Newton. It's 12,000 Newton. Weight is found out by mg. Okay. So we will be discussing the next question. Maybe. Okay. I'll give you some more another question paper, and the rest of the questions will be discussed coming Wednesday. Thursday from 9 to 10:30. Grade 11s are coming. If grade 10s are also willing to take part in that one, even though you can't understand what it says, because some of the syllabus parts will not be taught to you until you come to grade 11. And as usual, the grade 11 10s, if you are happy about this way of teaching and the discussions, you can introduce this one to the others as well on Russell.com. That's the website. My website there you got Anhydrous.com. There you can have my YouTube channel. Click on there and then you will be shifting to that one. 71814618. That's my number. Oh, my number is 7071 81 46183. Okay, and that's enough for today, I believe. We'll be seeing you again. Bye bye then.
Thank you, sir. Good night.
Thank you, sir. Nice to
Bye,
bye.
sir.
Bye bye.
Good night.
Good night.
Thank you, sir. Good
Thank you,
night,
sir.
sir.
Good night, sir.
Good night. Bye bye. Goodbye. Take care. Stay safe.